Hello guys, welcome to Master channel. So today is very important topic sulfuric acid corrosion, and this is experience in refinery, petrochemical and fertilizer plants. So let's start without any delay. So first of all, we'll understand the mechanism of the sulfuric acid. The fundamental mechanism is it's an electrochemical reaction where anodic side you can see this reaction occurs where iron is converted into iron oxide Fe2 plus and released to electron, and this hydrogen present in the sulfuric acid, it's absorbs to electron and convert in the hydrogen gas. So it's an anodic reaction and this is a cathodic reaction. So during this reaction the iron get converted into iron oxide, and this forms the iron sulfate layer. If this layer is stable, then further no more corrosion will occur and the layer will be work as a protective layer. But if this layer iron sulfate film is a protective layer not stable, then further it will iron will degrade and another layer of protective iron sulfate will form, and this will keep on damaging the layer by layer and cause the thinning. Okay, so high concentration at high concentration, the acid reacts with steel to form a protective layer of iron sulfate. As long as this film remains intact, the corrosion is lower. However, if the acid becomes dilute or velocity is high, temperature is high, then this iron sulfate layer film get washed away and exploring the metal surface to rapid corrosion. And so due to this corrosion, multiple failures in across the industry has happened that has affected the equipment, rotary machines, piping, tanks having multiple failures. Now, the basic thing is the stability of iron sulfate layer. This is iron sulfate layer you can see here. If this layer is much more stable, then further corrosion will not occur. So but if this layer is not stable, like in case of diluted acids, if our concentration is 98% and above, there is no issue. But if it is a diluted acid, if there is increase in temperature, there is then there will be chances of aggravated corrosion. So iron dissolution and hydrogen elevation will happen uh, if this iron sulfate layer is not stable. So basically, uh, we have to confirm that the protective layer of iron sulfate which get formed during the first reaction, this should be work as a protective layer and further stop the corrosion. But if it not if is not a protective layer, further it will expose another layer and lead to the catastrophic failure. So higher concentration above 90%, 98% of sulfuric acid, it's very good for carbon steels, but if our concentration is lower, it's a dangerous zone. Now we'll understand the corrosion rates for sulfuric acid. So here percentage of sulfuric acid, concentration, and here this side we have taken the temperature. Now you can see the 98% comes approx here. So at this area of 90%, there is a corrosion of below 0 to 0.5 mil. So this 0 to 0.5 mil corrosion will occur in this zone where the R concentration is 98%. So here the corrosion rates are lowest. Further, if we decrease the concentration, the corrosion rate will increase. Also, if we increase the temperature, the corrosion rate will increase and it will go as high as 200 mpy. So it's a dangerous zone. So we have to see the iron concentration, the temperature should not be sufficiently high, and the temperature should be low, approx at ambient, and the 98% concentration or above 98% should be there in carbon steels to avoid such corrosion. Now, so what are the critical factors First critical factor is acid concentration. So in acid concentration, we have seen the concentration should be greater than 98%. So that will be a magical word. And the temperature should not be higher, it should be less. So the second critical factor is temperature. Higher temperature lead to the corrosion. So corrosion doubles at every 10 degrees Celsius increase. So higher temperature, more corrosion. Alloy content, we have to select higher alloys to avoid this sulfuric acid corrosion. The velocity will be should be less to avoid the damage of iron sulfide layer. Otherwise, the iron sulfate layer will get eroded and lead to the further corrosion. So velocity should not be very high. Velocity should be considerably low. The contamination in the sulfuric acid is also exaggerate the corrosion. Then presence of the oxidizers like oxygen will also aggravate the corrosion. So this we have to take care. These are the critical factors. Now the most important thing is when we are cleaning vessel for inspection for handover of the vessel, we have to ensure that the prior to putting the water in the vessel or tank for cleaning, we have to ensure that we have properly neutralized the vessel by certain caustic basic material, basic chemical. So first of all, we have to neutralize it. Otherwise, the concentrated sulfuric acid, which are on the walls of the tank or vessel, will cause the serious corrosion when carbon steel uh, uh, vessel get emptied. So we have to take care of this during when our vessel or tank is getting handed for the inspection. Now the metallurgy selection. So carbon steel, we have seen the basic is carbon steel. So this can be used about 98% and under ambient conditions. Now when we want to upgrade it, we can upgrade to 316L, then further high silicon iron, then alloy 20, alloy B2, then alloy C276. This is the highest resistance. So we have to select the material based on economic factor. We have to upgrade the metallurgy based on our concentration for lower concentrations and basically at higher temperature and higher flow velocities. So to make the our iron sulfide layer intact and strong. Now this is iso-corrosion chart for the sulfuric acid for various metals. So you can see here this is the sulfuric acid percentage and this side is the temperature in degree centigrade. So up to here you can see this is the carbon steel. So carbon steel we can use here only approx 98% concentration and at temperatures up to 20 or 30 degree below ambient. But when our temperature increase or concentration increase, now we have to upgrade the material. This is a duplex 2205. This is also 2507 duplex. Then it comes 904L SS. This is super duplex. Then titanium here, very for very diluted acids, you can see the concentration of 10 here and temperature up to 70 degrees. So this is for titanium metallurgy. So likewise, we have to see the iso-corrosion curve and we have to select the metallurgy. Here we have seen titanium for 10% concentration and up to temperature 60-70 degrees. Then alloy B, you can see this is the curve and here temperature up to 50 to 100 we can use for concentration of 10 to 90%. Okay, and this is niobium alloy C, you can see. So depending on our sulfuric acid concentration, our temperature, we have to select our metallurgy like zirconium, tantalum. So likewise, we have to select a metallurgy for sulfuric acid services based on the temperature and sulfuric acid and velocity. Now the thing comes how to prevent the sulfuric acid. So first of all, we corrosion is minimized through the proper material selection, which we have seen. So proper material selection is very important, and proper operating within design velocities. So metallurgy, material selection. Then he has told that alloy 10T, alloy 904L, hashed alloy C276 resist the diluted acid corrosion to form a protective iron sulfate film on the surface. Then acid product streams can be washed with the caustic to neutralize the acid. So we have to, during inspection, neutralization is very important. We have to neutralize it properly for the inspection. So these are the ways to avoid this. So we have to ensure the solubility, uh, stable iron sulfide layer. Then there should be low flow, low velocity. There should not be high velocity. There should be no deformation, and the temperature should not be much to avoid the sulfuric acid corrosion. So these are the incidents you can see which has happened earlier across the industry, various industries. So we have to be extra cautious in, like in refineries. We have sulfuric acid plants and alkylation unit, we say. In that, we have to be more proactive because we are manufacturing large amount of sulfuric acid. Then in petrochemicals also we are using sulfuric acid for various reactions. In our fertilizer plants also we are using sulfuric acid in our cooling towers, for water, cooling water treatment. Then we also using DM plants also. So that's how we have to avoid this sulfuric acid with proper metallurgy selection, proper precautions during the operation. Now, with related to the sulfuric acid, there are two more damage mechanisms: hydrogen grooving and horizontal grooving. So we will see that in next lecture series. So thank you to watching to the end. Hope you have enjoyed this technical session, and please subscribe my channel for more technical insights. We will be back with more technical things. You will enjoy it. So thank you very much. Thank you.